Hello everyone, welcome to Coders Camp. We are at third day of December LeetCode challenge and we are going to cover maximum product subarray in this video, which is one of the commonly asked interview questions which seems simple but really a interesting question to solve. So the input given here is a integer array nums with both negative and positive values, and we have to return maximum product of any subarray in this given array. So let's understand this with an example. So we have to return the maximum product of subarray from the given array. So first let us see what is the brute force approach. So as you all know, by brute force it is a very simple problem. So we'll be putting this into a for loop and starting with the very first element, multiplying with every other element in the given array, and whichever gives the maximum product, we will save that. Same way we'd be starting from our second element and then extending it to the next element till it reaches the end of the array. Same way we'll start from the third element and extend it till the array. So this brute force approach is going to solve in big O of n cube time complexity, which is actually not so good time complexity, and we have to solve this in big O of n time and big O of 1 space. So how are we going to do it? So let's start considering each variant of input. Let's consider the first scenario would be all integers are positive. So in this case, whatever you multiply any number with any number, the value is going to be increasing no matter what. For example, starting with the very first element, the product is going to be 1, and the first two element is going to have the product of 2, and then the next first three elements are going to have the product of 6, and then finally 24. So now there is no matter what, the product is increasing. So if all numbers are positive, then the possible highest solution could be the product of the prefix values or the suffix values, which is nothing but the product could either be starting from the first value till the last but one value, or the product could be starting from second value and goes till last value. Why? Because this is a product of subarray. So how do we decide which product has to be our result? So which is very simple. So whichever set gives you the maximum value would be a result. So if all the numbers are positive, then the product is going to be either the first n minus 1 elements or from the last till first the second element. So now there could be an edge case in this scenario that is having a 0. So consider we are having a 0 in between. Then in that case we cannot consider this product from first to second last. Same way in the reverse. So what would happen if there is a 0 in the middle or somewhere in the array? So which means we can either have our product till 0 or after 0. So that is what going to happen, because once 0 comes, the whole product is going to become 0. So in that case, whenever there is a 0 comes, it is clearly that you cannot include the 0 in your product array. So you can either have your solution till here or after here. So what are we going to do is, if there is a 0, then we are going to initiate our product value back to 1 and then start multiplying from the next value to 0. So that's the only possible solution. So whatever maximum value, though you have 240 or something, once you encounter a 0, you're going to start calculating your product from 1. So this is one scenario. What if there are negative values? So consider this array with all negative values. So now let's start calculating the product. So starting from -1, considering the same way that we product whole sum and ignore any one value. So -1 is going to be -1, and -1 comma -2 is going to be 2, because there are two negative values, and then whole sum till here the product is going to be -6, and finally it is going to be 6. So here if you see, what would be the maximum possible product if we have to ignore either this element or this element? So if we ignore either of the -1, the product is anyway going to be -6, which is not the largest value out of all. So this method will not work for the negative values. So what would actually give the maximum product in this array, which is -2 comma -3. They both are negative values, so it will give a positive result of 6. So how do we explore this part in this array? So to do that, we are going to handle the memory or something to hold the multiplication progress of both negative as well as positive values. For example, so till here, the product is going to be 2. So we are going to maintain what is the minimum value so far and what is the maximum value so far, because sometimes a negative value could help us to get a maximum product in a subarray. So the minimum value is, so the minimum product is going to be -2. If at all we start our multiplication from this element, we would get -2 as the minimum multiplication value. And the maximum value is 2, because if we consider from -1, the multiplication of -1 into -2 is going to be 2. So far we calculated min and max. So coming to the next value, which is -3. So let's calculate the minimum and maximum value till here. So what would be the minimum possible value? So if we multiply our maximum value 2 with -3, it is going to give you -6. And our minimum value -2, if we multiply that with -3, it is going to give you 6. So here a negative value actually contributed to a maximum product. So here max is this and min is this. We still have one more element left, so we are going to further explore it. So now comes to -1, what is the minimum and maximum value? If we multiply -6 with -1, that is going to be the minimum value so far. And if we multiply with -6 and -1, it is going to give you 6. That is the maximum value so far. So here overall 6 is the maximum value of any subarray we have come across. So that is going to be a result. So hope this is making sense, which is pretty simple. We are going to have a pointer at every position that calculates minimum value and maximum value so far and pick both the multiplication with the number, and from that it is picking minimum value and maximum value so far. So this is going to help us to calculate the maximum product in the array at any subarray. So this is very similar to Cadence algorithm, which we have used for calculating maximum subarray sum, but the same idea implemented in a different way. So this is going to work in big O of n time and big O of 1 space complexity. So let's go to the code now. So yes, as I said, we are going to have the sum from left and right and finally calculate which is the maximum. So let me declare my result is equal to the first value in our array, and L is the product from the starting element, and R is going to be the product from the end element towards start. So let's iterate the elements. So as I said, we are going to calculate our L, which is going to be the product from the starting element. But here, as I said, we need a edge case, which means if we have a 0, we have to handle it. So we are going to add a condition that if left product is equal to 0, then we are going to start from 1 and multiply it with the rest of the product. If not, we are going to pick the value of L, which is nothing but the product so far, and multiply it with the rest of the value. And same goes for right product. So we check if the right product reached 0, then we are going to start with 1. If not, we are going to pick the right value, and then we are going to do the product with the rest of the elements from reverse. And as I said, for negative case or any case, we are going to update our result with the maximum value at each step. And yes, finally return the result. Yes, this is it. Let's run and try. Let's submit. Yes, the solution has been accepted and runs in 1 millisecond. Thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.